Hey everyone, it's Craig here again with the Valustra Research Alliance. Thanks for tuning in to this next video in the Getting Started series with Valustra. At this point, you've used the product a little bit, you've seen Valustra, you've seen how we've taken a team organizational structure and converted that into a team topology, but you might be asking yourself, well, how does Valustra do that? So in this video, we're just going to take a moment to just explain how Valustra uses VSRA and graph analysis to go from team organizational structure created in a way where we're specifying the support network to a team topology. So how does Valustra do that? How does the VSRA do that? So when we look at the 4 team types that exist in team topologies, we see that there are these 4 teams that are all working towards trying to be as autonomous as possible, but still integrating with each other, still working with each other to provide value to each other in some way in order to provide value to the end user ultimately. And so we've got these 4 types: the stream-aligned teams, the enabling teams, the complicated subsystem teams, and the platform teams. Each one of those teams provides value to one or more of the other teams in various ways. And this diagram shows how that generalized flow of value or exchange of value happens between the different team types. Now, you won't find this diagram in the Team Topologies book. This diagram came out of the white paper that myself and Stephen Walters created when we first got together and started to try and figure out how to do VSRA in a way that made sense using techniques like graph theory. And so what happens in VSRA is that we take this generalized pattern of flow and establish that as a graph. And so you can see in this diagram that we've got these green arrows that represent the generalized pattern of flow between the 4 different team types. And you can see that enabling teams provide value to stream-aligned teams, complicated subsystem teams, and platform teams. And I should point out that each one of these green arrows, this doesn't represent a handoff between teams. This is the continuous exchange of value that's happening between the teams all of the time. So it's not a case of one team waiting for some other team to provide them with something. But we can see that there's this generalized pattern that happens between the 4 team types. So enabling teams providing value to all the other 3 teams. Platform teams typically providing value to complicated subsystem teams and to stream-aligned teams, but not to enabling teams. Complicated subsystem teams providing value to stream-aligned teams, but not to platform teams or enabling teams. And of course, stream-aligned teams kind of accepting that value from the other 3 teams. So what we can see is if we join these teams together with these arrows, we could actually create this as a graph. It is a graph. So we could draw it if we wanted to with little circles, with lines between the circles. And what we would see is this graph is what we call an acyclic directed graph. What that means is there are, first of all, acyclic. There are no cycles. So I can't start on any one of these teams or nodes and follow the arrows to get back to where I started. So you notice that with enabling teams, there's no way that I can follow a path that would get me anywhere back to the enabling team. And same with all the other team types. There is no cycles in this graph. The other thing is that it's a directed graph. What does that mean? It means these arrows only go in one direction. So we can see that the arrows just go one way. There isn't an exchange of value that's happening in both directions, typically. And again, this is the generalized case. So it's not the only case, but it's generally what we see in most organizations when we think about the teams with these 4 different team types. So once we have this graph, and particularly once we have this generalized graph, we can reason about the graph by using graph centralities. So graph centralities are a mathematical method of finding values within the graph that represent certain attributes or things about the graph that we can reason about. And we use 2 graph centralities in VSRA. We use PageRank and betweenness centralities. The PageRank centrality tells us how important is a node to the rest of the graph. What that really means is how much of the graph is kind of pointing towards that node. So how is that node kind of really central to the graph? How is that node really creating a whole bunch of dependencies for other nodes? And if it's got a lot of those, if it's highly dependent upon by other teams, then it's very central and it's very important to the graph, and it will have a high value of PageRank. Betweenness centrality tells us how much is a node on the path between two other nodes. So if we were to take a path from one node to some other node, how many nodes would we kind of cross across that would be sort of in the middle? Those nodes that are in the middle that we have to step through to get from one node to another have a higher value of betweenness. And what we find in team topologies is that stream-aligned teams and enabling teams tend to have a low value of betweenness because they're typically on the edge of the graph or of the organization, enabling teams being one end and stream-aligned teams being the other. Enabling teams typically is where things kind of start, and stream-aligned teams is where things kind of end. Whereas complicated subsystem teams and platform teams have a higher value of betweenness. They tend to be in the middle of the graph. So they tend to be in the middle of things. And with regards to PageRank, stream-aligned teams and complicated subsystem teams both have low values of PageRank. That means that generally, from a graph centralities point of view, they are not as important to the graph as the enabling teams and the platform teams, which have a higher value of PageRank. So when we perform the graph analysis, we get these values for these centralities. We can find the middle value or the mean value or the median value for the total graph that we have. And we can subdivide our nodes of the graph into high and low values, high values of PageRank, low values of PageRank, high values of betweenness, low values of betweenness. And you can see that then identifies the teams because they fall into the one of the quadrants that we've got in this chart. So that's how VSRA and how Valustra is performing graph analysis to make classification of team type within the organization. So I hope you find that interesting and useful. And next time that you're playing with Valustra, or next time that you are watching maybe one of the other videos, perhaps you'll think to yourself, I see, I get now how Valustra is making that connection between organizational structure and team type classification. In another video, we'll start to look at how the fine values are computed in VSRA as well. And this is really when we start to take a look at how are the teams interacting with each other, what are those interaction patterns they're using, and in particular, how is that impacting their cognitive load within that organization, and how does VSRA and Valustra use what we call the cognitive slope to determine that effort that teams are making to perform work when they're interacting with other teams. But we'll look at that in another video. I hope you found this useful. Please keep watching the videos, give us feedback, let us know how we're doing. Good to see you on this video. We'll see you on the next one. Thanks, guys. Bye-bye.